So now that you have gone over the storm drain lectures, you should know all about where to get data and resources with a brief introduction into Flow 2D, an overview of inlets and junctions, outfall storage units, conduits, pump orifice, and weir. Now we can start on the simple storm drain tutorial. There's two tutorials. The simple storm drain tutorial will be a very simple, shortened uh, version of the storm drain model. And the advanced storm drain tutorial will be the full, all of the different storm drain system. As you can see, you can kind of see it right here. So it has conduits, inlets and junctions, orifice, outfall, pumps, storage units, and weirs. It has just a little bit of everything to show you how to set up those different features. We're going to stick with the simple storm drain unit. So this video covers create a storm drain from shapefile with the complex method or advanced method. Now what we want to do is simplify the entire tutorial so it's a little bit easier and it doesn't take so long to get through. And let's go ahead and start with our simple storm drain tutorial. And the first step, of course, is to import the data to our system. If you come over here, wait, let me grab our thing right here. If you come over here to the self-help kit and you go to lesson 3, you'll see that there should now be two different folders, simple storm drain folder and advanced storm drain folder. The simple storm drain folder has only 3 shapefiles in it, the conduits, the inlets and junctions, and the outfalls. And I can drag and drop those right onto the map. And then I'll just delete this rating table warning check because we'll be rewriting that when we import our rating table. So back over here, and if you want, this is the way I do it. I just don't like these floating around up here, so I like to put them in here in that storm drain group. And then the first thing that we'll be doing is connecting these to our storm drain, our Flow 2D storm drain network. So if I start with my storm drain editor, I can do this select components from shapefile. And unfortunately, I've already done this a couple of times, so these are already filled, but I want you to do this very carefully. So most of these will be almost correct, but we don't need everything. So name is okay. The type is okay. And again, Flow 2D or storm drain types are 1 through 5. And we talk about that in the inlets and nodes video. Invert elevation is the invert of the conduit at that, or invert of the junction at that location, and the conduits connect to the invert, or possibly the invert plus an offset. The maximum depth. So this is basically the bottom of the node to the surface where the rim elevation is. That's where we want our rim elevation to be, is the bottom of that node to the Flow 2D surface. We don't need initial depth and surcharge depth because we are going to be doing the simplified lesson, so we can leave some stuff out. We do need a length and perimeter. If it's a type 1 or 2, this would be the curbside length of the opening. And if it's a grate or type 3, this will be the perimeter. And then width and area, same thing. So if it's a type 2, this will be the width of the kind of that sloped sagging area of the type 2. Or if it's a grate, it will be the area. So if it's a type 2, it'll be a width. If it's a grate, it will be the area. Yeah, right. This next one, you need to be careful because this one's always set to curb height, and that's wrong. So this one actually needs to be set here. And so if it is a type 1 or 2, this would be the curb opening. That's the height. If it's a type 3, this would be the sag. And again, all of these are in feet. And then if it's a type 5, this will be that surcharge depth for popping the manhole cover. That's the weight of the manhole cover. Weir coefficient here, and the feature switch, if it's a type 4, it can have a feature switch set to 0, meaning that it's a horizontal feature like a oddly shaped grate. And if it's a head wall, then you set the feature switch equal to 1, and that means the flow starts at the invert of the feature, not at the rim of the feature. And then we aren't going to use any of these in our simple system, so we won't be covering any of those. Outfalls. Okay, you see we're pointing right to our outfalls. Name is pretty easy. I think this one does everything correctly, but we don't need these three, so I just turned those three off. So name, invert elevation, whether or not it has a flap gate, and then the allow discharge switch for the flow2D out data file. So if it's set to 0, then all the flow that goes to that node will be treated like a sink, like a normal depth sink. And anything that is, well, actually, it won't just be a normal depth sink. It will be based on the outfall type. And then if it's set to 1, then it will exchange water back to the flow2D surface, either to a channel or a basin or something like that. And then outfall type, of course, it'd be like normal, fixed stage, tide, or time series outfall condition. And then you would need these other guys right here if you used a different type other than normal. For conduits, we have a name. Now, you don't actually need the from or to inlet nodes because we have a calculator that will fill those. So you can leave these two blank. Inlet offset and outlet offset, I also left these blank because I don't have any in this project. My conduit shapes are all circular, so we only have a maximum depth. So this circular geometry means your maximum depth is in feet. So C shape, barrels, maximum depth. That's all you need here for the simplified lesson. Length and Mannings, we are not using any initial flow or any max flow in the simplified lesson. We are not applying any losses in the simplified lesson. Flap gate is just an on-off switch, yes or no. Once you've checked and double-checked all of these, you can click Assign Selected Fields. So once you click that, it's going to copy all of that data into the Flow2D layer, the Flow2D storm drain layers here. And now your storm drain lesson is part of your geo package. I'll click OK. This message right here is letting us know that we need to process the auto assign link nodes. And that's the next thing we'll do. So I'll click OK. And then I'm going to uncheck these. I don't want to remove them until after my first run has been checked and validated, but I can uncheck them. But if I hit this assign button again, I probably want to come back and recheck those, turn those back on first before I run that assign again. Sometimes I mess this up and I'll use a wrong variable. And then when I run it, I realize either A, it won't run, or B, my results look really weird and different. And so I will realize that I made a mistake when I was assigning these. So be very careful about that. So the next thing to do is to auto assign the links to the nodes. So what's going to happen here is that every endpoint of the conduits of the polylines of the conduits is going to be assessed, and then it's going to look for a node that's next to it. And we're putting that search distance to a buffer of 3 feet. You don't want it any higher because then you could potentially like pick up a different node. So we want that to be about 3 feet. That seems to be good. And then you click yes. And what that's going to do is it's going to assess every conduit, and it's going to find the upstream and the downstream node, and it's going to apply it to the table. And if everything worked out okay, it's going to print this message. And if something didn't work out okay, it's going to print a different message so you can go fix those nodes that weren't right. Usually the reason why that doesn't work correctly is because one of these conduits will be like more than 3 feet away from its node. So if that's the case, you just turn the editor on for the conduits, or you might want to move the node instead, and you turn on the snapping toolbar, and you'll click that end. See, I've picked it up, and then I'll snap it right to that node, and then I'll save that. I'm going to not save it because I just didn't really want to make that change. I just wanted to show you how to do that. And we don't have to do that. We don't have to, of course, if it was something was messed up, you'd run this again, but we don't have to do that because we didn't need to run it again because ours were valid. Here is the final, or not the final step. Here's the next step to set the storm drain control variables. And so you can put whatever you want here. Then the time, control, and report variables. We do report everything. I mean, that's up to you, but I always report everything. The start date for the simplified lesson is not important because we do not have to sync this to any other data. The start time is important. It needs to be the start time of the simulation, and of course, our start time is 0. And the end time is important. It also needs to be the full simulation runtime. It can't extend beyond that, and it can't stop before that. It needs to be the full simulation time. We're running our model for 10 hours. And as you can see, it has a tooltip to tell you that. This report step is not important. Well, I mean, it's important in that you can set it to whatever you want, but we default it to 0.1 hours, which is 6 minutes. So that's the interval at which we report to the RPT files. And then the advanced and hardwired options. So the advanced options, I'm not going to cover these because like I said, this is the simple lesson. So if you need to know more about these, you go to the storm drain documentation or the storm drain guidelines, or maybe the advanced videos have some information about these. I can't remember. Flow units are going to match the QGIS project. The rest of these guys are hardwired, meaning that even if you did change them in the INP file, FlowPro engine and the Flow2D storm drain engine are still going to hardwire these to flood routing for dynamic wave, initial damping for partial, and normal flow limited condition will be set to both. That you cannot change. I mean, you can change it, but it's not going to matter. It's still going to use what's hardwired. So we'll click OK. And then make sure that you check Simulate Storm Drain because that's going to turn on the button in the control panel. That'll turn on your button in the control panel. Now we need to import that Type 4 table. So you can see right here, we have this Type 4 table. It's tab or space. It doesn't really, I think it's tab delimited. Depth on the left, discharge on the right. We got that probably from HY8. And we're going to import that by clicking the file folder, selecting the one with the exact same name as the name of our conduit. And it tells us one rating table is imported, and we want to check this guy right here. So if I check that, you can see that we have a rating table, and it is assigned to the inlet with the exact same name. And then minimize that and click OK. And the final step will be to schematize the system. And then once you schematize it, you do want to check to make sure that these blue arrow, this is where your project connects to your grid. So you want to make sure that these are set where you want them to be set. For example, this one is a little off. It probably should be set to this grid element or this grid element, but it's a little off. And then also make sure that your outfalls are also assigned to the correct node. In this case, our outfalls all outfall to the channel. So we want to make sure that this little green dot is on a left bank. Now we are not applying our outfall to the bank. We are applying it to the cross section. And so we want it to ski away from other features. So we keep it away from the hydraulic structure, the culvert, and put it one node downstream of the culvert and make sure it's assigned to the left bank. And this one's barely making it. It's right on the edge, but as long as the green node shows you that that's right inside there, then that does not matter. Because this outfall is interfacing to the channel cross section. Everything is complete now. You're ready for your test run. So all you have to do here is your quick run. So if I go run Flow2D and I go quick run, inside lesson 3, I have a simple storm drain run. I think I need to empty that out real quick. Okay, and then we'll select that. And you can see that everything is ready to export. And we are using DAT files, not HDF5 files. Click OK. It's exporting everything right now, and as soon as I click OK, it will start. And if it runs without any errors, then you can continue on with your processing, which basically in our case will be to let the run finish, and then we review our storm drain. So that'll be the next video. Okay, so I'll go ahead and stop this one here.